All right, so if you're a data scientist trying to make that leap into an AI or MLOps role, there's one skill that you absolutely, positively have to know: software containers. Today, we're going to dive deep into what they are, why they're basically the foundation of modern machine learning, and how you can actually get started. Let's get right into it.
Oh man, this phrase. I think we've all said it. We've all heard it. We have all felt that deep, soul-crushing pain when something breaks in production and you just can't figure out why. This one sentence is the cause of so many wasted hours. And it's the perfect place for us to start, because the technology we're talking about today was invented specifically to kill this phrase forever.
So, what is this magic solution? It's called a software container. The easiest way to think about it is as a neat little package that bundles up your application's code with everything it needs to run. I mean everything. The libraries, the tools, the right system settings, the specific versions, the whole shebang. It's like a portable environment in a box that guarantees your app will run the exact same way, no matter where it is. It finally puts that "works on my machine" problem to bed.
Okay, now to really get good at this, there is one thing you have to understand right from the start. And that's the difference between an image and a container. A lot of people get tangled up here, but trust me, it's actually super simple. Just think of it as the blueprint versus the actual building. Let's stick with an analogy. Let's say you're baking a cake. The image, that's your recipe. It's a static, read-only blueprint. It lists all the ingredients, your code, your dependencies, your libraries, but you can't eat the recipe, right? It's just a set of instructions. Now the container, that is the actual cake. It's the live, running thing that you create from the recipe. You can start it, you can stop it, and you can use that one recipe to bake a dozen identical cakes, or containers.
So we get what they are, but why are containers such a massive deal for MLOps specifically? Well, it all comes down to closing that huge gap between building something on your laptop and actually getting it to run reliably in production. It makes the whole process just seamless. And for MLOps, this is basically a superpower. First, you get reproducible environments. That means the model you trained on your laptop is going to behave the exact same way when you train it again in the cloud. No more weird surprise results. Second, you get sane dependency management. You know the nightmare where one project needs an old version of a library but another needs the new one? That's gone. They're totally isolated. Then you get seamless portability. Your container just runs, whether it's on a Mac, a cloud server, or a tiny edge device. It doesn't care. And finally, containers are the absolute foundation for orchestration. If you want to scale up with big, powerful tools like Kubernetes, you need containers. They're the little Lego bricks of the whole system.
Okay, that's enough theory. Let's get our hands dirty and see how this actually works. The tool pretty much everyone uses is called Docker, and at its core is a simple little text file called a Docker file. This is where you, the developer, actually write out that recipe for your image.
So here's a pretty classic Docker file for a Python project. Let's walk through it. From just sets our starting point. We're telling Docker to begin with a nice, clean, lightweight version of Python 3.11. Workdar is like creating a project folder inside the container to keep things tidy. Now look closely at the next few lines. See how we copy only the requirements.txt file first, and then we run the command to install all those packages? We're doing that before we copy the rest of our application code. That is a total pro move, and we'll see why in a minute. Finally, CMD just tells the container, hey, when you start up, this is the command I want you to run.
And here's the beautiful part. After you write that file, it only takes two simple commands to bring your application to life. First, Docker build. This command reads your Docker file and builds that static image, your recipe. Then Docker run. This takes the image you just built and launches it as a live, running, isolated container, your cake. And that's it. Your entire application is now perfectly packaged and running.
So you've got the basics down. You can build an image, you can run a container. Now let's talk about a few pro tips that will make your whole workflow faster and more efficient. This is the stuff that really separates the beginners from the experts.
Pro tip number 1. In any modern team, you've got some people on new Apple Silicon Macs and all your production servers are running on Intel or AMD chips, right? Those are completely different CPU architectures.
Instead of dealing with the headache of building separate images for each, you can use Docker buildx to build one single image that runs perfectly on both. It's the real build once, run anywhere dream.
Now this next tip, this is going to save you so much time. Docker builds its images in layers, kind of like a stack. And if a layer hasn't changed since the last time you built it, Docker is smart enough to just reuse it. This is called caching. And that's exactly why we installed our dependencies before copying our source code. Our dependencies rarely change, but our code changes constantly. So Docker just reuses that big, slow-to-install dependency layer and only has to quickly rebuild the tiny code layer on top. This simple trick can literally cut your build times from minutes down to seconds. And for all you deep learning folks, this one is for you. If your model needs a GPU to run, please, I am begging you, do not try to manually install all the CUDA drivers inside your container. It is a world of pain. Just start your Docker file from one of the official NVIDIA base images, like NVIDIA/CUDA. They have done all the incredibly hard work for you, making sure everything is perfectly compatible. This will save you days of frustration.
So there you have it. You've taken your messy, unpredictable local environment and turned it into a clean, reproducible, and portable container. Your model is perfectly packaged up and ready to go. So the only real question left is, now that you have this perfect little box, are you ready to take it and scale it to serve thousands or maybe even millions of users?